Right, okay, good morning everyone. Just going through the KA3 Acids and Redox, which I would like you to go through and look at your own paper and make corrections, but also obviously consider why you didn't get something right. That's the most important aspect of going through work like this. Okay, so let's start. Question 1. These are multiple choice, the first questions, as they will be in your exam. You can eliminate the two of these immediately by working out the oxidation state of chlorine in HCl, which is -1, so you know that it can't be B or D. And then obviously you just need to look at the others. You've got to come up with C. Obviously this is, multiple choice, you don't want to spend too long on it. But it's pretty straightforward, really, to work out the oxidation state of chlorine in those substances, providing you know what you're doing in working out oxidation states. Okay, here, you may not have come across this term, to be fair. If something is a reducing agent, it means that it has been oxidized. In the same way as if something is an oxidizing agent, it means it's been reduced. So, effectively, you're asking here, the Cu plus ion has been oxidized. And if we look at the equation, we can see that it has lost an electron. It's gone from Cu plus to Cu2 plus. But if you weren't clear on that term, hopefully you are now. Question 3, which one is not a redox reaction? Now, the first thing that stood out to me when I saw this question was all of these had an element on one side of the equation. So you can tell straight away that oxidation or reduction has occurred. So just check straight away equation D to see if that is the answer, and it turns out to be the answer. You have to kind of employ quick thinking strategies when you're doing these multiple choice questions. This one, little bit involved for 1 mark. So if I was doing this in an exam and I didn't sort of get the answer straight away, I would definitely move on and come back to it. But it's straightforward calculation, to be honest, if you can recognise what's going on. They've given you 2 equations. Quickly look at the ratio between your Cu2 plus and I2, because it says that copper-2 ions can be estimated by the addition of an excess of potassium iodide. So you've got Cu2 plus and I minus, that's your potassium iodide. By titration of the liberated iodine, so you've got you're liberating the iodine, so you then titrate that with the thiosulfate. Now if you look at this, the ratio's 2 to 1 Cu2 plus to I2 and 1 to 2 I2 to S2O3, which means you've got the same numbers of moles. The ratio is the same for Cu2 plus and S2O3. If you look at this, yeah, 2 to 2, 1 to 1. So once you recognise that, it's pretty straightforward. Take your grams, take your molar mass, and work out the number of moles, and then you can work out your volume. Okay. Right, here we are. Oh, right, yeah, no, going back to this one, it's an extra step here. So this is a pretty harsh question for 1 mark. If this was a written question, you'd get at least 2 marks, because you have to convert your cubic decimeters to cubic centimeters. Yeah, because it tells you here in cubic centimeters. So, yeah, quite not a very straightforward question for a multiple choice. Okay, oxidizing agent. So this is the term I was talking about before, which means that the substance is being reduced. Okay, now hydrogen is one of the exceptions. Remember, we do get H -1 in hydrides. So, I mean, that's the kind of stood out straight away. Might not for you, you might have to quickly go through them and try and work them out. Okay, question 6. Again, this is one of those, you're looking at 2 equations, but you've really just got to recognise here that the Cu2 plus is 2 to 4, so 2 to 1 basically, and here is also 2 to 1. So your I2, the ratio of Cu2 plus to S2O3 is 1 to 1. So that, well, if you can work out the moles of S2O3, which is the information you're given, I believe, I'm trying to look quickly. Yeah, you've got sodium thiosulfate, you're given a volume and a concentration. So we can work out the moles of S2O3, 2 minus, and then we can put that into our equation and work out a percentage. But again, there are a few steps in it. So if you start finding yourself in a question like that in an exam, you start getting muddled up, leave it, move on, don't waste time on it, come back at the end. If you don't have time, you just quickly pick any one. You've got a 1 in 4 chance. Okay, question 7. Now this is pretty straightforward stuff, I think. Calculate number of moles in a volume and with a concentration, so that's not hard, so you work that out. From that you deduce the number of moles of sodium carbonate. Ratio is 1 to 2, so we're going to divide it by 2. Then obviously hence deduce the number of moles in the original 250 cubic centimetres, so this is in 25, so in 250 we need to multiply by 10, and then we're calculating the MR of the hydrated sodium carbonate, so MR is equal to mass over number of moles. Yeah, so you're given the mass in the question, 3.01. You've worked out the moles in the 250, round it up to 124. Okay, this is a different hydrated sodium carbonate, and you're given the MR of this. You're told that the MR of the whole thing, the hydrated, is 250. So you can work out the MR of the Na2SCO3 on its own, which is 106. So if you take that away from your original 250, which is the MR of the whole thing, you're left with 144, which must be your MR of water, moles per gram of water. So if you divide that by 18, that's going to tell you how many waters you've got. Yeah, 18 being 1 water molecule, obviously you want to know, so that's the MR of 1 water molecule, that is the MR of 8 water molecules. Okay. Right, part C, ideal gas equation, very important. Some of you didn't use the correct symbols. These are, you have to know which are capital letters and which aren't. So it's a small p, capital V, a small n, a capital R, and a capital T. And if you didn't use the correct symbols, you didn't get that mark, which is silly. You should definitely get that mark. Okay, and then obviously you had to go on and calculate the pressure. So you had to rearrange the equation for pressure. You had to work out the number of moles from the information up here. You've got 325 grams of argon gas. Yeah? So 320. Oh, I've forgotten to write in the molar mass of argon because I've put the wrong value. I think it's 39.9, but I can't remember exactly. I think originally I rounded it up and then I crossed it out. I think it's 39.9. So just double check that, which comes out to 8.15, which then of course goes into the ideal gas equation as the number of moles, gas constant, temperature you're given in Kelvin, so it's easy, and you're given the volume in meters cubed, so you don't have to do any changing here of units, and then you could give your answer in pascals or kilopascals. Okay. Question 8. So one of these, yeah, we're given 2 equations actually, but you're not actually really using them in that sense. You're just being asked to look at the 2 different stages and you work out the oxidation state. So we're looking at sulfur here. We've got -4 for oxygen, so it's got to come back to 0. It's a neutral species, so -4 + 4, 0. And here we've got -8 from the oxygen. We've got +2 from the hydrogen, so -8 + 2 gives us -6, so we need +6 to come back to 0. What has happened to chlorine in stage 2? So it's gone from being an element to -1, oxidation state of -1, which means it's gained an electron, which means it's been reduced. Balancing this equation, it's not the most straightforward equation to balance. I think you just put a number in really, maybe put a 2 in here to start with and then see how that works. Think, oh no, that's not worked. You just have to keep multiplying up until you get what balances. Okay. Again, it's 1 mark, so if you get yourself bogged down in it, don't worry. Ionic equation for the formation of silver iodide. You must know your ion charges here so that you know the ratio. So you've got silver ion, Ag+, that's +1, iodide ion, -1, so they form silver iodide, Ag, I-. Okay. So we don't need the nitrate ion in there, and we don't need, silver nitrate, and yeah, so we've got silver nitrate plus a solution with iodide ions in it. So the nitrate bit is not involved, and the metal of the iodide solution. So if it's potassium iodide or sodium iodide, it's only the iodide ion that's involved, which is why this is an ionic equation only. But if you don't know your ion charges, you're not going to get the ratio correct. Okay, define reduction in terms of electrons. Oil rig, yeah, reduction is gain of electrons. Straightforward, you should know that. Okay, oxidation states of nitrogen in 3 different species. NO and NO, it should be NO2 there, shouldn't it? Okay, but you're told the correct ones here. So NO3-, yeah, +5. Work that out. So it's -6, +5, but it has to come back to -1 because it's got a minus charge. So the nitrogen is +5. Here it's +4. Here it's +2. Don't forget to write the plus sign. And then if you look at those, what's happening to the formation of NO2 from NO3-, yeah. So is it? It's gone from +5 to +4. So has it gained or lost an electron? It's gained an electron, so it's been reduced. Okay, question 10. You're given some information about a salt of tartaric acid, and you're given a general formula HXA. You are given a volume and a concentration of this tartaric acid, and you're told a volume and a concentration of the sodium hydroxide that it reacts with. Yeah. Then it's just going through the calculations. It's laid out for you. It's a pretty guided question. So your moles of HXA, yeah, it's the obviously number of moles equals concentration times volume. Amount of moles of NaOH, all this information is coming from the question. And we can see that we've got twice as many moles of NaOH to HXA, and we know that it exactly reacted with it at that point. So if there's twice as many moles, then there must be twice as many H's, so X must equal 2, and the calculation is there. You're dividing the number of moles of NaOH by the number of moles of HXA. Okay, Where are we? Construct an equation for this reaction again. If you don't know your ion charges, you won't get this right. So CuO, copper, it tells you the copper nitrate anyway, so you don't have to worry about that. Copper 2 oxide, so you know that the oxidation state of copper is 2, so it's going to be CuO. You should know the formula for nitric acid. That's one of the formulae that you need to know. You need to know hydrochloric, sulfuric, nitric, and ethanoic, I believe. Oh, and phosphoric. They're the 5 acid formulas you're expected to know. And we get a salt plus water. That's really 2 very simple marks. Okay, so we've got an empirical formula for our hydrated copper 2 nitrate. And we're asked to write the formula for hydrated copper nitrate to show the water of crystallization. So remember, I mean, a lot of you got this wrong, you know, that the water of crystallization has that dot in it in the formula, and it is a certain amount of water. Now, looking at that formula, you start with hydrogen, divide it by 2, which gives you how many waters you've got effectively. So it's going to be 6. Then you obviously need 6 oxygens from the 12 that are there, and then the rest of it you put into the anhydrous bit of the formula. All right. So you're told it's hydrated copper nitrate, so you know the formula for copper nitrate. So really all you're looking for is how much water there is. Okay, just divide the 12 by 2. Okay, this one, a number of you didn't answer the whole question. Hydrochloric acid is a strong acid. What is meant by the term strong and acid? So a lot of you told me what a strong acid was, which is fully dissociated in water, but a lot of you didn't tell me what an acid was. An acid is a proton donor. Okay, and then here, this one is the state symbols, which a number of you get confused about. You've got an acid, this is going to be in solution, you're at HCl, and invariably your other reactant will also be in solution. You're going to produce a solution of the salt. Water is always a liquid because it's a pure substance. And obviously carbon dioxide is a gas. So these 3 are aqueous because they're all in solution. This is a gas, this is liquid. And then what you would see, some of you still didn't get this right, you have to say what you would actually see, and you would see bubbles or effervescence. Okay, and that's an easy mark really. Okay, so that's the end of that. So make sure you've made the corrections on your paper, and I will then give you the mark scheme to it so that you can have the official mark scheme as well as my feedback video. Bye for now.